So we're going to dive in. So you can see that strategically we have been peeling the onion on the challenges. We started with connectivity. We're driving all the way to the business model at the very end. You don't want to miss the last panel. The last panel is how we pay for the whole thing, right? Now, this panel is very crucial because we just talked about AI and ML, and we have the devices out there, 50 billion things. But then you have to really realize, well, okay, well, I got 50 billion things. It's all coming to me. I got my data scientists, but how does this all get managed? I need databases. I need tools. I need maybe specialty things like blockchain, right? It's like, how do you manage this? I need architecture. So this is like, we're in the back of the kitchen with the chefs that cook the stuff, right? And so now we're going to talk about how do you cook the stuff? How do you make the pizza? How do you make the jambalaya, right? So I'm going to ask them to introduce themselves, tell you they're all great friends of mine, and I want them to share their title, their involvement, what they do. In many cases, they are in different, have different responsibilities. They have been in the industry for a long time. They're all superstars. So we'll start with David Forfia on my right, your left.
Hi, I'm David Forfia. I'm the Director of Enterprise Architecture and IT Transformation for ERCOT. So I'm an end user of the databases, and we'll talk about that. I'll be up here for the following panel because I do a lot of things outside ERCOT. I'm fortunate. So I'm also chair of the Smart Electric Power Alliance Technical Advisory Council. I'm a former SEPA board chair. I was the chairman of the board for SGIP, so I know a lot of things about standards. I'm also chair of the Gridwise Architecture Council, which does a lot of things outside and is a thought leader group that's sponsored by the Department of Energy. So on this panel, I'll be speaking in my role at ERCOT.
Yeah, please.
Okay. Brad Williams, I'm Vice President at Oracle Utilities, and I'm responsible for our operational solutions strategy and innovation. And I come from the industry as well, 20 years as a power system engineer at SoCal Edison and then at PacifiCorp. A little bit of time at Gartner as an analyst. That's where I first met Andreas, I believe. And been 10 years at Oracle. And it's exciting times coming from a power system background, electric utility background, to be able to apply these kind of technologies. And I'm kind of in a candy shop, if you will, because there's so many broad technologies that we can tap into that can help us solve some of these key problems that we've been talking about all day.
Vinod Tiwari from PowerEdge. I'm the head of business development. We're based in Australia, so not a US company, but I'm here at invitation of Andres to come and talk to you. And really thank you for inviting. I was almost going to say that I'm here only because of Andres, but we do have projects here. So when we finish here, I'm off to California for looking after the project that we're working with Silicon Valley Power with City of Santa Clara. What PowerEdge does is we've created multiple energy blockchain-enabled solutions in energy sphere. Flagship product is peer-to-peer energy trading. So there was a bit of a mention in, I think, Charles from Austin Energy and Paul mentioned as well that it would be nice if prosumer can actually direct the energy to one of the consumers that they would like to sell to, or maybe even gift the energy. Well, our platform actually allows that kind of facilitation of energy trading. There are other products as well, so we expand the solutions from energy trading to creating a virtual power plant type of solution where blockchain acts as a value transfer for once you're able to aggregate the excess capacity to make it available for network control services or WAN management or even for frequency control ancillary service type of thing. Using blockchain, you can actually transfer the value of that service being offered instantaneously in near real time as soon as you read the energy data. Some of the projects that we're doing here in the United States actually includes peer-to-peer energy trading, working with American PowerNet in Pennsylvania. Scott Helm was here yesterday. He had to unfortunately leave this morning. So we are working in partnership with American PowerNet, and I briefly mentioned Silicon Valley Power, which is owned by the city of Santa Clara, where we using blockchain for verification, tracking, measuring, reporting low carbon fuel standards program. So probably talk a bit more about it further down this conversation.
Yeah, thank you.
My name is Rachna Handa. My background in energy is I started at DOE with the Obama administration with the Recovery Act and transitioned into the Office of Electricity and Energy Reliability, where I focused on energy storage research and microgrids. And since then, I've been at EPRI doing microgrids, and I'm now at OSIsoft, where we are building a microgrid on our campus. OSIsoft, for those of you who don't know, we've been around for about 40 years. We say we're doing industrial IoT before it was cool, so we are a data infrastructure company that has customers across the utility sectors. So we're in 100% of electricity markets. We are at ERCOT. We're in 80 to 90% of utilities. I don't know the exact number. I personally work on early product and innovation at OSIsoft, and so I'm helping with how our product integrates with distributed energy resources and microgrids. And I'm looking to thank you again for inviting me to the panel. I'm looking forward to the discussion.
Hi, I'm Reid Cataldo from Prysm Group. We work specifically in the blockchain industry. We work, I guess you could say blockchain is a general purpose technology, so we work across from the energy sector to the oil industry. We have some very interesting projects we're working on right now. Hopefully Andres can guide us into that. My firm, Prysm Group, I'm one of the co-founders. My position technically is Chief Product Officer. I really make sure that the many talented people on our team we can extract value and provide products that are very valuable to our customers. So we work as consultants. We provide economics and governance structure. So the governance that is not the legal part, but the economics part, the microeconomic structure. So how are the rules? How is your marketplace going to adapt over time? These are things that we develop. So we really focus, our firm provides really contract theory. It leverages market design, information systems, all surrounding incentives. So if you have a marketplace that you're developing, say maybe in the energy sector, you have a buyer and seller. Why are those people going to come to your platform? Once they arrive to your platform, they can either choose to use it the way that you actually intended them and want them to use it. They can try to game it, which means hack the system and extract value from it, use it how you don't want them to, or they can choose to leave. So our firm focuses on making sure that your intended goal of how you structure that marketplace is actually how it's going to be used over time. So yeah, thank you guys all for having me here.
Sure. Thanks for all being here. So let's get into it. So we'll start with the CISL, which is blockchain, and then we'll work our way down in the menu food chain. So you know, how many of you know what blockchain is? Anybody? Okay, everybody, excellent. So clearly, you know, it's a tool set. There are different flavors of that. We have, you know, two approaches on how that could be done. It's early stage in the game, so this is evolving quickly, right? Sort of like Web 1.0, HTML 1.0. It's moving fast. Some of these guys have been going at it for 5-6 years before anybody knew what it was, or maybe longer, you know, 10 years almost. And now the world's catching on in applicability. So I'll start with the chief architect in the room to my left here, and say, you know, just ask him really quickly. So David, blockchain plays a key role in every industry. Give us the sort of the wisdom of, do we need it? Why would we need it? You know, how do we go about consuming it?
Well, I say I have lots of titles at ERCOT. One of them generally is Chief Hatchet Catcher, and it's generally easier to catch them when they're thrown from the front. But if you ever pitch a business case that starts out with, we have this technology, And well, now we're hunting for a solution or a problem for it to fix. It's a difficult business case to make. One of the interesting things that came out this week from NASB is NASB is actually looking at setting up standards in the way to use blockchain for renewable energy credits. So the group started that this week. But the challenge I run into in talking about blockchain within an ISO is we've got really big systems that have to be ultimately reliable and that have been in place since the ISOs were formed. So you've got really cool technology, some of the most amazing electrical engineering things that have ever been done. And if I'm going to go through and say, what's the business case to go through and replace them, it's a tough sell. It is a technology-based discussion, and then you start talking about what's the ROI, what's the savings, what are you going to go through and enable. The use case that I tend to look for, especially from the ISO perspective and what we have to do from reliability, is where do we have something that's new, something that doesn't have an existence, someplace where I've got enough market power and market ask to be able to drive it. The use case I tend to point to a lot, especially within ERCOT and other venues where I present, is the food safe example that came out and used blockchain with IBM and Walmart to go through and secure the food supply chain globally. So that's a good use case. You had a player who had enough market power to drive the suppliers. It spanned continents, it spanned economies, it spanned jurisdictions. It was a super use case to be able to do that. But for applicability for my projects in the near term, it's a tough sell for me to go through and say, hey, take a system that we've had for the last 15 years. We have some minor modifications we'd like to make to it. We have some technical debt. Why don't we go through and completely rebuild the application from scratch and change the rules and how it works to go through and do it. So from an architecture perspective, from a business case perspective, it's a tough sell for me as a displace. It's a much easier sell for me when we start talking about something new, something that the market asks for, and something that the market needs that goes beyond what you can do with a central authority that has the ability and the legislative mandate to serve that role.
All right, so now that we heard the big hurdle, right? It's a big hurdle to get in there. What would the blockchain guys say, Vinod? So what are the use cases? What are you seeing? People are calling you. You're in business. You're flying all over the world.
Yes.
Why is this happening?
Yes, I'll actually start by we're not a technology which is looking for solutions. We actually, the genesis of PowerEdge is, so we're energy professionals who got into this. I was working 15 years as general manager retail and regulatory for one of the utilities in Western Australia. The other co-founders were also from energy innovation and disruptive technologies, etc. So the problem, and I'll probably have to give Australian example, excuse me for that, but that led into how we could use blockchain as a solution there. So Australia was one of the early adopters of distributed energy resources. At the moment, we have about 26% of households in Australia already have rooftop PV. So 1 in 4 house is already a mini power station. We heard this morning about energy grid not being linear anymore. It's very real for us over there. To incentivize the deployment of renewable energy or DERs, distributed energy resources, early on, the government offered multiple subsidies and incentives. One of that was premium feed-in tariff. So for me, and I do have 5 kilowatt rooftop PV on my house, 10 years ago, when I was not using that energy, I left home 8 a.m. every morning for Monday to Friday for work, only back 6 p.m. During the daytime, all the energy generated from rooftop PV was going back to the grid. I was getting a super deal, 50 cents per kilowatt hour as a premium feed-in tariff from my utility. And I was paying them, when I was buying the energy from grid, I was paying them 26 cents. So I was almost getting times 2. But obviously that was a subsidy in the system. Mm-hmm. It wasn't going to last forever, and it didn't. Mm-hmm. And in 3 years' time, we're now back to the grid pays me equivalent of wholesale energy cost. So it's 6 cents is what I get back. So down from 50 cents to 6 cents. So all of a sudden, the system doesn't seem very fair to me. I'm buying at 26 cents and selling back any excess to grid at 6 cents. As soon as the battery prices are cheap enough, I'm going to install a battery and direct all the excess energy into the battery. When I come back, I just use the energy that was stored during the day. So literally going off the grid. If not 100%, but by a significant, probably only buying 2 or 3% from the grid. If my neighbor does that as well, and if others in the community down the street do that as well, well, the grid's all of a sudden facing the death spiral that we talked about 5 years ago and always thought that it is too far away. It's very real. Actually, it is already starting to happen because some of the states, for the reasons best known to them, have actually now started offering subsidies for home energy storage systems. So battery is 50% being subsidized. A 10 kilowatt hour battery in South Australia, which normally costs $10,000, you can buy it for $5,000 because government subsidizes $5,000. So when that happens, your grid's obviously literally a stranded asset. And we do all know the value of grid. With my technology, I can turn the physical grid into a trading platform. Someone like me doesn't have to buy a battery, actually can sell that excess energy to the neighbor or someone down the street. Instead of 6 cents, if I can monetize it and get 16 or 18 cents, I'm really happy. My neighbor is happy because they're not paying 26, they're only paying 18. Grid can charge a wheeling charge. It cannot be the whole bundle transmission distribution charge because this energy is now only traveling 20 meters or 50 meters. So you create a t-shirt sized model or are you downstream to feeder, are you downstream to substation, and you create those kinds of different tariff. And it's already starting to happen in Western Australia. So we're doing it fairly large scale smart cities trial deployed in the city of Fremantle. At the moment, 80 prosumers and consumers are part of that trial, which is across the grid peer-to-peer energy trading. So that's one use case. We didn't put in blockchain.
So let me stop you there, because let me get this. So the government in Australia said, look, I don't have any more money to do central generation, so I'm going to tell my customers to do it. I'm going to give them an incentive to do it, but they're carrying the load, so whatever I'm giving them is not 100%, it's a lot less than maybe 30%, but they're going to build distributed generation. So that was happening, and you all of a sudden took your blockchain and said, we're going to become the Uber of this and connect them all so they can trade and sell back and forth, right? Am I getting this right?
Yeah, absolutely.
Okay.
Yes.
Okay. Are you all following what's happening?
And the reason we use blockchain, so we didn't come as a blockchain company looking for solutions, but we found blockchain as the best technology to deal with microtransactions because these transactions happening every 15 minutes and happening between prosumer and very small amount and happening between prosumer and consumer. So you need a trustless system which is time-stamped, immutable, no one can doubt it. So that's a great fit for a technology, for a solution, for an issue that needs to be solved.
Anything to add?
Yeah, absolutely. So Andres asked earlier who had heard of blockchain. I think it might have been about 80% of you. Can I get a raise of hands who's heard, maybe prior to PowerEdge, who's heard of valid application of blockchain, like a valid use case that makes sense? Okay, that's more than I expected. There's a lot of projects that are going on. I think TradeLens, that's one that has received a lot of marketing. IBM is good at doing that. If we have any IBM people here, way to go. But that really lacks in a number of things. So when we look at what is valuable use case, we look at what we call the 3 C's. It's coordination, control, and cooperation. So commitment. So when we actually look at projects about why blockchain can be valuable, we're looking at these 3 things. So we're actually looking, we just made an announcement earlier this week. We're working with the Inspector General Office in the country of Colombia right now. You can read, that's like a very valid use case for anybody that didn't have their hands in the air about how to get rid of, minimize corruption at the government level. That should be an interesting one. It's a pilot project for World Economic Forum, which we'll study those results, and hopefully we can take that to other cities in Colombia and throughout the world. So that'll be interesting. I think one thing that I'd like to share with you guys today is, we have people from different industries here, really focused on energy. We have a paper that we just published with partners of J.P. Morgan, Johnson & Johnson, and World Economic Forum also last week. We leverage a lot of academics, and somebody said here that the data scientists are hard hires. So we compete with Amazon and Uber, Facebook, and these sorts of companies, Airbnb, on hiring economists out of school. So it's a challenge. We have a research on an economic thing called the holdup problem. And basically why this is applicable probably to every single company that's in this room is it shows that right now, blockchain is interesting. It allows us not to do things that we wouldn't have been able to do before, but in this case of something that we wouldn't have been interested in doing before. So when you're coordinating stakeholders at maybe the Fortune 500 level, you have opportunities to work with competitors, right, to achieve a common goal, whether that's R&D or if you're sharing energy across different companies. So before blockchain, you have what's called a zero-sum game. It means when you join a partnership, let's say in this case with a competitor, there's going to be someone that has the IP ownership or the ownership of the database, right? At some point in time, whether it's a month or in 5 years, there's going to be a change in that relationship. Either Ford or General Motors might want to change what that database or R&D platform are going to be used for, or whoever might have control might try to change the stakes and start charging value from the other party. So this paper that we show through math is how you can develop a blockchain database to eliminate the zero-sum game, and you can actually essentially clone these databases through blockchain. So while you're contributing to these databases over time and getting shared learning, you're not going to be held up over time. You can effectively leave without cost, right? That other party isn't going to be able to hold you up and charge you and extract financial gain from you, and you'll be able to leave with that, whatever you've built over the last 5 years, that exact database. So interesting study, very applicable to all companies. So I encourage you to read that.
Yeah. So that's a great segue into. I need to get the database guys involved, right? So blockchain is a technology, right? It's a sort of a methodology, right? There are different ways of sort of making that, right? So you can write blockchain on C# or JavaScript or so on and so on. And there's all the different platforms and flavors of this stuff. And ultimately, blockchain, relies on database technology, and it has its own sort of, general ledger, high-level description of what it is. But there are different sort of mechanisms under how we make this sausage of that. So what is the comments that Brad and Oracle can share, or Rachna from OSIsoft around, and then billions of data points getting ingested, moving around. Some of them are going through a blockchain phenomenon. What's going on? Help me understand, how do I make the pizza?
So I wanted to kind of respond, and thank you for that segue. I'm from California. I realize that the rest of the country is not as progressive, especially in the energy space, as maybe what California is doing. And
you think?
I think that's what I've heard. But I think the idea is that our customers are in multiple situations, they're in multiple jurisdictions, and multiple use cases, and so many of them don't want to. They've already invested significantly in their databases and in their data and in data structures. And so what we are looking at is, how do you take the existing IT infrastructure and then leverage it for upcoming and emerging use cases? And so for our perspective, where we're headed with blockchain is that's kind of far out, but we also have realized, as you said, data is the new oil, and people will need to share data. And so we have products such as Pi Community and things that allow people to share data between their Pi systems in a way that allows them, again, to own and control the data, but then collaborate in an R&D setting with others or within a community. So we're actually demonstrating that on our site, where we're sharing data between tenants, between the landlord, between the EV charging, just to show a connected energy community that's sharing select data in order to enable control, however, not giving away all the data that is owned by each entity. So I'll let the gentleman from Oracle, but we also recognize that data sharing is important. It's just we're not think people are at the point of blockchain yet.
Yeah, I would agree with that. I think if we just look back at kind of the evolution of the database, and certainly totally see the exponential growth of data and the importance to leverage that in more near real time to help drive operational performance. And I think that's what a lot of the discussion has been about. And we look at relational database, spatial database, time series database, real-time in-memory database, getting to the speed, engineered systems that help drive that performance, and distributed database. Now Oracle has autonomous database, which is cloud-based, self-configuring, if you will, self-healing, those types of things. And there's a lot of capability within the database itself that has evolved over the years. And certainly I do believe in blockchain. I do also acknowledge that the applications are limited today. We heard a really good one here. The Western Australia one, I think, is very good. And as we move more of our intelligence out to the edge of the grid, the distributed processing, and then having peer-to-peer transactions, that makes perfect sense for a blockchain type of application, where we need to have distributed ledger, we need to have security, we need to control access, and probably have some mistrust on some of the other participants that we want to mitigate that or control that. So I think too often we want to try to use this cool hammer to find the right nail, and I think that's going to be key. And I do think that in many cases there may be better solutions that can solve some of those problems with just standard database technology.
Yeah, those are great insights. I do like the concept of using blockchain to eliminate corruption. That would be awesome. So let's circle back, all of you, around cloud. So we heard before the round trip, computing moving to the edge. There's still a lot of people that say that the cloud and the compute on the cloud is so significant and large that it can do the round trip pretty fast for what is needed and the use cases. Maybe not for 2 or 3 things around control systems. It's just about everything else it could. So, and again, your trades that happen in the stock exchange are happening at millions of transactions per second, and they're going to the cloud and back, right? So clearly you need good telecommunications for that to happen. But assuming that all is there, where are you guys on the blockchain side, on the database side, on the architecture side of an ERCOT? Where's the state of cloud as it relates to performance compared to 2 or 3 years ago? Where is it heading? Can I really, I'm the proponent. When I was at Austin Energy, we tried to push to the cloud everything but the SCADA systems. We didn't really do all of that then, but a lot of things are in the cloud. The billing, many things are in the cloud. It makes sense to have them in the cloud. Okay, and I believe that at some point you should be able to push everything except for a few things that need to be controlled real time. And the question to the panel is cloud there? Is cloud mature enough to handle all the needs of the industrial world yet, or not, or how long before? Who wants to start? And let's go brief on those answers.
Okay, I'll start out with a depends answer. So working in some place that 95% of our data and what we do is governed under both high security and NERC compliance. No, we don't have a lot of things up there at this point. We're still addressing the compliance issues that it takes to be able to do the things that an ISO does, and for the in-scope portions of what many utilities do, that's the challenge right now that we're trying to address. However, as you start talking about how you could go through and isolate the systems, how you can go through and move the data, what you can do with a load code type application development platform, as you start talking about how to get to the data, no matter how much money someone gives me, I can't change all of the systems at ERCOT in 1 year. It can't happen. There's no way, and no one's going to give us that amount of money. But as you start talking about how you can go through and isolate those systems of record, which move at a much, much, much slower pace than things that we want to change for UI and what would be our digital content, that's really where cloud is prime time ready. If we can address the compliance requirements, and my friends at NERC have a SAR out that hopefully will address that and make sure that we can satisfy the compliance requirements in addition to the security requirements, I think that makes it much easier for those of us in the regulated space to be able to use cloud as a technology to be able to get there.
Mm-hmm. Right.
Yeah, so there's a number of areas to deal with when we start talking about cloud. Certainly, pace of change, I think, is a big one, is that things are changing very quickly right now, and it's very hard for utilities to keep up with that pace of change. Even Austin Energy, it's like these things are changing so fast, and that is the value of the cloud solutions. Is that's what they do, and even things like cybersecurity, keeping up with patching. It's like that is becoming more and more difficult as we add the complexity to microgrids and all of these other pieces that are coming in, and that's where things like cloud start to make sense. Is like, oh, even data scientists. It's like, if that was a service that was around my cloud infrastructure, wouldn't that be nice? Because I can't hire these data scientists anymore, but the big companies do. Mm-hmm. So anyway, those types of things. Also, the idea of cloud as a distributed architecture, or fog computing, where you're running these distributed apps in other infrastructure, substation environments, or things like that, also starts to make sense and can be a service that is locally or distributed in its management. So lots of opportunities there.
Yeah. Who wants to just keep it brief?
Yeah, just
Cloud in your space, how is it giving you everything you need? Is that the way it works? Is that?
Well, we actually write all our transactions on blockchain directly, so we don't use too much of cloud, but we're picking up data from these distributed energy resources. So the data transfer obviously is through cloud, and it works the best. So we think that is the solution for now.
Okay.
And my only adding to this, because I think everything was well said, is that cloud as an intermediary is a good idea, but given some of the workloads on the data that some of these entities have, it's very expensive to use the cloud. Like, it's easy to put data in, but you better pay up when you want it out. And so I think that's something, if you're in a cost-constrained environment, you need to think about before moving to the cloud.
Yeah, I would probably further on what you said earlier. There's a time and place for blockchain. Someone mentioned regulation. You're not going to change all of your data and put it on the blockchain overnight. We are seeing, over the course of history, regulation, from the government changes all the time. It's constantly changing. So we are seeing some companies, actually primarily in Europe right now, that are doing, adopting blockchain for very specific use cases. Actually, right now, due to regulatory changes, tracing origin for material, for example, that's a big thing right now. So, in very specific use cases, it could make sense for a larger company to have that adoption.
Any questions? We got 2 mics. Just shout it, and I'll repeat it. Go ahead.
So this is maybe more about the peer-to-peer energy trading and distribution. So maybe you've got ERCOT, PowerEdge, and maybe blockchain ties into this too. But given that your peer-to-peer trading goes over the distribution, the wires, and somebody put the capital in and manages that and probably pay, ratepayers probably pay for some of that. How do you, and maybe the answer is different everywhere, probably is, but how do you keep that competitive so they're not getting gouged both directions? Okay?
Yeah.
And customers coming out.
Yeah. So the question is the price of the transaction. What is the cost, total cost, and is PowerEdge or paying somebody else for that, or how does that work about? I think he explained it in Australia, but Dave wants to jump on it.
So let me start out with the
And
highest level, talking from the wholesale market. We do a lot of things to enable transactions amongst our market participants. That framework and that structure has, started in 1999. ERCOT was the first ISO. Those rules have been established. But the way to think about this, honestly, when you start talking about what I have to do working at an ISO and what you would do on a distribution network, let me use the Oreo example that has been used before. Think about what Nabisco does to make an Oreo at a factory. That's my world. Now go through and try to make an Oreo at your house. Will the things that I have to do and what's necessary to make a wholesale market work translate specifically down to the distribution level? Honestly, I've had this debate a number of times on the Gridwise Architecture Council. The answer is there's very specific things you have to do at the distribution level that are much, much, much different than what happens at the wholesale market. And that's the reason why it's not as simple as saying, take the cool power engineering and market stuff that you do at the wholesale level and shift it down. It is a different paradigm.
So back to the cost. He explained it in Australia. Just brief. Go back to that cost, and you explained it.
Yeah, and so the cost and the expansion probably would be when peer-to-peer energy trades is only one part of it. And obviously the logic there is if the energy is only moving in a very closed environment in the neighborhood, then the consumers and prosumers should not be paying this full bundle transmission costs, or energy is not traveling from large power station anymore. It's just in that community. So what Western Power is trialing, which is one of the utilities that we're working with, is a new innovative tariff. They've come out with almost like a subscription fee. So you pay a daily supply charge. You can use the network as much as you want to. So you could store energy using someone else's battery and take it out from there, or you could do peer-to-peer transactions. It's still a pilot. It's not a commercially deployed solution, but it's being trialed in a significant pilot stage. And just quickly, I'd like to expand. So the full solution is not just at peer-to-peer level. Once you put in batteries in the system, and we're looking at commercial projects of tens of thousands of batteries and solar PV integrated with these household residential level, with either one retailer or multiple retailers. These could act as, obviously through DERMS, and also many battery storage systems also have these software available where you could orchestrate the batteries into as a single, multiple distributed batteries, a single battery or clusters of batteries to offer multiple services to network. So it's not just for consumers' financial benefit. It is actually offering maybe because of the high penetration of rooftop PV, there is obviously this duck curve that was mentioned earlier on. So other issues that the grid faces. The solution actually comes from the distributed level. You don't have to have spinning reserve, big power plant ready to offer any spinning reserves. That can come from your distributed batteries. So these, and also it could be an option for the retailer as well, because wholesale electricity market also is not fixed price all the time, at least in the markets that we know around the world. Prices can be very high, and it could act as a physical hedge where instead of buying energy from wholesale market at high peak events, you buy from your consumer base.
Absolutely. Another question? Anybody? Yeah. So it sounds like we're tired. So that's valid. I'm overload, right? So here's another question. So we heard from Scott that he's sampling and collecting data every second for every device. He didn't say how he makes the sausage or the pizza. I assume that he's using some of your technologies. So my question is, again, back to quickly to maturity of where we are. Again, from the software point of view, cloud, databases, tools, do we have everything we need to go from 10 billion things to 300 billion things? Can we you know, or are we too far away? Do we need quantum computing for that, or do we have already what we need? Where are we? Anybody want to take a jump on that?
I can take a quick jump.
Yeah.
And this is not my area of expertise, but there is collaboration between what they call high performance computing and high level data analysis, where you're taking big data and basically merging it with high performance computing. And my personal opinion is no, we're not there. It's still very much in the realm of academia. I think that there will be advances made. So I think maybe the cloud is there from a raw hardware perspective, but I think the algorithms that are required to integrate both of them are still a ways.
Anybody?
Yeah, I would think we're getting. Well, I would say we're getting closer. Yes, we're not there entirely. In fact, that's a big part of the work that we're doing is using more parallel processing, distributed architecture to enable the scale that is required. And again, we support advanced distribution management and DERMS, and some of the optimization does not need to be optimized centrally. It actually doesn't make sense. It actually should be optimized at the edge, things like volt-var, even DER optimization. But utilities need some kind of overarching authority for safety, reliability, make sure people are safe, crews are safe, tag out, lockout. So there needs to be an architecture that supports this multi-million point count and models that are much more advanced than the EMS or the transmission models. And so that requires an architecture and systems that can support that. So they exist. They haven't all been put together yet.
Right.
The way I look at this, with the ERA funding, a number of synchrophasers got installed across the transmission networks, and we now have virtual synchrophasers to going in and doing the samples. Lots and lots of data. The question is, I know the use cases that are of value to an ISO. We look at it after an event. We're going through and doing that. We're looking at phase shifts in real time. But at some point after the real time, how long do we have to retain the data? Because at some point, right, what happened, the 60 measurements in that second, I don't know how much helpful information that's going to provide my shift supervisor to go through and make a decision about whether or not he needs to go through and do a verbal dispatch to go through and resolve an issue, or whether or not we're going to let the systems do it. So that's the challenge that we're looking at when you've got lots and lots of measurement. You've got the measurement. The question becomes one of, what business value can you derive out of the data? And then the risk that everyone looks at, because I have this debate about purging pretty much every budget cycle. Well, what if we find a way to get value out of that data and you've let it go? Right? And that becomes my debate, which is one of the reasons why I love using the Pi platform. Right? It cuts that data down immensely. But that's really the challenge as you get into this.
Yeah. Last. Oh, go ahead.
Maybe just a
quickly.
From my perspective, we're working a lot on consortiums. So you can see in the energy industry, there's an energy blockchain consortium, automotive industry as well. And I think a number of people have touched on this today. It's about industry standardization. That's a hurdle. That's something that we're working on right now. We're helping out with that through governance, allowing these companies to work together. But we have I would say, a ways to go before we have the standardization, and that's actually implemented on. So we're creating the foundation, and I think we're on our way.
Okay. Well, we're running out of time, so I'm going to thank the panel. Thank you very much.